Okay, section 2. Part A. Question 1. A particle moves along the x-axis so that its acceleration at any time t is greater than 0 is given by a of t equals 12t minus 18. So from first sentence, we already have the function of acceleration. Okay, next sentence. At time t equals 1, the velocity of the particle is v of 1 equals 0, and the position is x of 1 equals 9. So we have two information here. One is when t equals 0, v equals 1, v equals 0. And t equals 1, the position equals 9. Okay, question A. Write an expression for the velocity of the particle v of t. The function of the velocity, we can find it by integrate the acceleration function. So a of t. And a of t is 12t minus 18. So integrate 12t is 60t squared. Negative 18 is negative 18t plus constant. Now we have to plug in the information that at time t equals 0, at t equals 1, v equals 0. So 0 equals 6 times 1 squared minus 18 minus 1 plus constant. So negative 12 plus c equals 0. So c equals 12. So our final function of velocity is 6v of t equals 6t squared minus 18t plus 12. So right here. So 6t squared minus 18t plus 12. Okay, next question. Question B. At what values of t does the particle change direction? So we all know when the velocity is equal to 0, the particle changes direction. So we just need to set velocity equals 0 and solve for t. So 6t squared minus 18t plus 12 equals 0. And t squared minus 3t plus 2 equals 0. Factor so one time is 1, another time is 2. So the answer of the question B, one is 1, another is 2. Okay, next question. Question C. Write an expression for the position x of t of the particle. So we can find the position function by integrate velocity function. which is 6t squared minus 18t plus 12 dt. And equals 2t cubed minus 9t squared plus 12t plus constant. Another constant, we call it C prime. Okay, now we just need to plug in another given condition. T equals 1, x equals 9. So 9 equals 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 plus constant. So 9 equals 2 minus 9 minus 12 plus constant. So 9 equals negative 7. Oh, plus 12 is 5 plus C prime. So C prime equals 4. So the expression for the position is x of t equals 2t cubed minus 9t squared plus 12t plus constant 4. That is the answer of question C. Question D. Find the total distance. Traveled by the particle from t equals 3/2 to t equals 6. Like I said many times before, anytime we have a question to find the total distance of a particle, we need to watch out whether the particle changes direction. If so, we have to break the integration into two parts. A positive integral one, it is traveling to the right in our question. And a negative integral means it is traveling to the left. But because in section 2 part A we can use calculator, we have an easier way to solve it. We can just, let me write the expression. We can just integrate from 3/2 to time t equals 6 and add absolute value of velocity function. So it's 6t squared minus 18t plus 12 dx. By using calculator, we can simplify this question. So the final answer is 176.500 round to 3 decimal place. Okay, next question. Question C. A solid has its base as the region R, whose cross-sections perpendicular to the x-axis are squared. Find the volume of solid. In order to find the volume, we need to find the area of each cross-section, which is the side squared, because it is a square. So A equals side squared, and the formula is as follows. So from A to B and A dx. In our case, A equals 0, B equals 3. And the perpendicular and the cross sections is squares, are squares. So it's side squared dx. And the size and the side equals g of x minus f of x. So plug in 19 minus x squared minus x squared plus 1 and squared dx right here. So it equals, combine like term, 18 minus 2x squared dx equals 0. So 324 minus 72x squared plus 4x to the fourth dx. So it's 324x minus 24x cubed plus 4x to the fifth over 5 from 0 to 3. Okay, next. When we plug in x equal to 3, we have our expression. Which is 1944 over 5. Okay, next question. Question 3. Consider the equation x squared minus 2xy plus 4y squared equals 84. So we have an implicit equation. Question A. Write an expression for the slope of the curve at any point x and y. That means we need to find the value of dy over dx. We need to find the expression of dy over dx. So we have an implicit equation here. So next step, we just need to take a derivative of both sides with respect to x. So left is 2x minus 2x prime y plus 2x times dy over dx. Okay, next term is 8y times dy over dx. And take a derivative of a constant, the answer is 0. Okay, next. Two x minus 2y plus 2x dy over dx plus 8y dy over dx equals 0. And keep simplifying it. So 2x minus 2y minus 2x dy over dx plus 8y dy over dx equals 0. So 2x minus 8y times dy over dx equals 2x minus 2y. So dy over dx equals 2x minus y, 2x minus 4y. So is x minus y, x minus 4y. Okay, so this is the expression we need. Okay, next question B. Okay, question B. Find the equation of the tangent lines to the curve at the point x equals 2. In AP exams, the question to find the equation of a tangent line is very frequent. So we must know the process very well. The first step is always find the expression of dy over dx. The step 2 is always find a point. Normally, it's a point. And step 3, plug in this point and use y minus y1 equals slope, dy over dx equals slope times x minus x1. And better here we use x1, y1 to represent this point. So let's solve our question. First, we already know dy over dx expression, which is y minus x minus y over x minus 4y. So plug in the point we have. Here we only have x equals 2, so we need to solve for y. So plug x equals 2 into the function given by the question. So 2 squared minus 2 times 2 times y plus 4y squared equals 84. So 4y squared minus 4y minus 8 equals 0. So y squared minus y minus 20, here divided by 4, equals 0. So factor equals 0, and so y equals 5 or y equals negative 4. So we have 2 points here. One is 2, 5, and another one is 2, negative 4. So we will have 2 tangent lines. Okay, next. So we plug in the first point. So the first slope is equal to 2 minus 5 over 2 minus 4 times 5. So it's negative 3, and 2 minus 20 is negative 18. So which is 1 over 6. Slope 2 is 2 minus -4 is +4. And x2 minus 4 times -4. So numerator 6, denominator is 16, 18. So the second tangent line, the slope is 1/3. We need more room. Okay, so use the formula. Use point slope formula to solve for to find our equation of the tangent line. So the first one, y minus 5 equals the first slope, while 6 x minus 2. That is the first equation of the tangent line. The second is y minus -4, which is positive, equals 1/3 x minus 2. So that is the expression of the second tangent line. Okay, next question. Question C. Find the second derivative of function dy over dx at the point 0 and the square root of 21. So we have to use the implicit differentiation again. So dy over dx is y minus x for y minus x. So use the quotient rule. So first one, dy over dx minus 1 times 4y minus 1 minus dy over dx times 4 minus 1 times y minus x. So simplified. For y minus x dy over dx minus 1 minus y minus x for dy over dx minus 1. Okay, next step, we substitute this fraction for dy over dx. Okay, we don't need to simplify further. We can just plug in the information we have, which is a 0.0 square root of 21. So it equals 4 times the square root of 21 minus 0 and squared. So 4 times the square root of 21 minus 0, and the square root of 21 minus 0, 4 times the square root of 21 minus 0 minus 1, minus the square root of 21 minus 0 times 4 times the square root of 21 minus 0, and 4 times the square root of 21 minus 0 minus 1. Okay, simplified. So it's 16 times 21. That is the denominator. And the denominator here, the square root of 21 we cancel out, so it becomes 1 over 4. 1 over 4 minus 1 is negative 1. Negative 3 over 4 times 4 the square root of 21 minus the square root of 21. So here it cancel out again. And this also 4 also cancel out. So it's 1 minus 1. 1 minus 1 is 0. So this is 0. Continue. So this is 3, 3, 6. Top is cancel out. Is negative 3 the square root of 21. So this is our final answer. Next question. Water is draining at the rate of 48 pi feet squared per second from the vertex at the bottom of a conical tank whose diameter at its base is 40 feet and whose height is 60 feet. So first, from the first sentence, we know one rate, which is right here, the draining rate. So it's dV over dt equals, because it is a draining rate, that means it is decreasing the volume. So we need to add a negative in front of the rate. So it's negative 48 pi. Okay. Another information we get is that it's the shape of the tank is a cone. And about this cone, we know the diameter is 40 feet, which means the radius is 20 feet. So this is R equals 20 feet. And the height is 60. So this is 60 feet. So that means this is 60. Now we set the R of the surface is small r, and the height is small h. Okay, now question A. Find an expression for the volume of water in the tank in terms of its radius at the surface of water. This is a very easy question. As we learned, the formula of volume of a cone is 1/3 times the base, the surface of the base, or the area of the base, times height. So it's 1/3 times the base. The base is a circle. I change another color. The base is a circle. So the area is pi times small r squared times h. So h is this height is h, but this side in terms of its radius. So we need to know the x expression in terms of r. So h, as we know, the radius is 20 and the height is 60. And this triangle, the surface, I change another color. So this blue, I shaded in blue. So this blue triangle and this big triangle, they are similar figures. So that means small r over small h, or lowercase r lowercase h, equals capital R over capital H, which is 20 over 60, which means 1 over 3. So that means H equals 3R. I write here. So H equals 3R is the relationship between H and R. So I erase it. Okay, continue. So it is 1/3 times pi times r squared times 3r, which is pi r cubed. So that's the answer of the first question. Next one. I write here. Question B. At what rate is the radius of the water in the tank shrinking when the radius is 16 feet? From question B, we have another information. So R is at the point is equal to 16 feet. And at what rate? So this is obviously an unrelated rate problem. So I said the key point or the center thought of related problem is always relationship between different variables. So at what rate is the radius of water in the tank shrinking? So they require us to evaluate the dr over dt 1r equals 16. But we only know is dv over dt is negative 48 pi. So we need to find the relationship between v and r, and as we have got from the question A, v equals pi times r cubed. So if we take the derivative of both sides with respect to t, we can get this equation. So dv over dt equals pi times 3r squared times dr over dt. Now we find the relationship between dv over dt and the dr over dt. So now we can substitute negative 48 pi for dy over dt equals pi times 3r. R is equal what? 16. At that point, r equals 16 squared times dr over dt. So now we can solve for dr over dt equals negative 48 pi over 3 times 16 squared times pi. So pi cancel out. 3 and 14, 8 cancel out. We get 16. We factor a 3 out of the denominator. Now we factor a 16 again from the denominator and numerator. So now we get 16. So it's negative 1 over 16. So this is the answer of question B. Now the question C. How fast is the height of the water in the tank dropping at the instant that the radius is 16 feet? So still at the same point, R equals 16 feet. And how fast is the head of the water in the tank dropping? So they require us to evaluate dH over dt at R equals 16. And as we know, the relationship between h and 3r is h is 3r. Okay, so we take the derivative of both sides with respect to dt. So we get dH over dt equals 3 dr over dt. So now it is very easy, very simple. So dH over dt is 3 times the rate of r. We already know is negative 1 over 16, so which is negative 3 over 16. Okay, that's the final answer of question C. Next question. Let f be the function given by f of x equals 2x to the fourth minus 4x squared plus 1. Question A. Find an equation of the line tangent to the graph at point -2 and 17. So we did this type of question many times. First step, take the derivative of function dy over dx, or we can write it in this way. And so it's 8x to the third minus 8x. Okay, now this is the first step. The second step, plug in x equals -2. So f prime of 2, or -2, is 8 times -2 cubed minus 8 times -2. So it is 8 times -8 plus 16. So 8 times -8 is -64. -64 plus 16 is -48. So which is the slope of the tangent line at point x equals -2. So now we have the slope. We also have a point. So by using the point slope form, we can find the tangent line. So y minus 17 equals slope, which is -48, times x minus -2, so it's plus. So we simplified y equals -48x minus 79. So this is the equation of the tangent line. The question A, we finished. Question B, find the x and y coordinates of the relative maximum and the relative minimum. Verify your answer. So question B, to find the minimum and the maximum, we need to find the critical points first. So how to find the critical points? Set derivative to be 0. So it's 8x cubed minus 8x equals 0. Okay, we factor 8x out of the expression. It becomes x cubed minus 1 equals 0. So x equals 0. x2 equals positive 0 or positive 1. We just write 1. Okay, another x is a -1. So we have 3 x values. One x equals 0, 1, and -1. The derivative are all equal to 0. So there are 3 critical points. Now we need to determine which one is the local minimum, which one is the local minimum. We set the second derivative. We need to find the second derivative equation. So dy over dx, second derivative equals 24x squared minus 8. This is our second derivative function or expression. Now we need to plug 0, 1, -1 back to plug these 3 values into the second derivative expression to see if they are greater than 0 or less than 0. So the first one, f prime double prime of 0 equals 28 times 0 squared. So the first term is 0. 0 minus 8 is -8. The second one is 1. So it's 24 minus 8 is 16. The third one, -1, is still 24 minus 8 is 16. So we can tell when x equals 0, the second derivative is negative, which means that is a maximum, local maximum. And when the second derivative is greater than 0, that means that is a local minimum. So these two are local minimum. But they require us to find the x and y coordinates. We only know the x coordinates. So now we just need to plug them back into the original equation. So f0, f of 1, f of -1. f of 0 equals 2 times 0 minus 4 times 0 plus 1. So is 1. The second, 2 times 1 minus 4 times 1 plus 1 is -1. The third one, 2 times -1 to the fourth is 1, minus 4 times 1 plus 1, still -1. So our points are the first one, 0 and 1. The second is 1, -1. And the third is -1 and -1. And the first one is local maximum, or we call it relative maximum. The last two is the local minimum. Okay, this is the answer of question B. Question C. We need some room. Question C. Find the x and y coordinates of the points of inflection. So we need to set the second derivative to be 0. So when the second derivative is 0, at that point it is an inflection. So 24x squared minus 8 equals 0. So x squared equals 8 over 24, which is 1 over 3. So x equals 1 is a negative, 1 is a positive. So we have two x values. In order to find the y coordinates, we need to plug the x values back into the original equation again to solve for y. Okay, I need more rooms. Okay, f of the square root of 1/3 equals 2 times and the answer is first one, 2/9 minus 4/3 plus 1. So the final answer is negative 1/9. F negative the square root of 1/3 is 2 times 2 fourths still the same. So the final answer is still negative 1/9. So the 2 points of inflection is first one, the square root of 1/3 and negative 1/9. The second one is negative the square root of 1/3 and negative 1/9. Okay, that's the answer of question C. Question 6, the last question. Grain is being loaded into a silo at the rate of g of t equals 400 times e to the negative t squared over 4 feet cubed per hour. So from the first sentence, we know the rate of the grain being loaded. So dv over dt is 400 times e negative t squared over 4. Okay, where t is the number of hours that is being loaded, and they give us the domain of the function, which is between 0 and 8. And next the sentence, at time t equals 0, there is 100 feet squared of grain in the silo. From second sentence, we know the original amount of grain. Okay, third sentence. Grain is also being removed through the base of the silo at the following rates, where R of t is the amount of grain being removed in feet squared per hour. The domain is the same from 0 to 8. So we can tell the amount of grain being removed. That function is given by a table. Okay, question A. Estimate the total amount of grain removed from the silo at t equals 8 hours using a left-hand Riemann sum and 4 sub-intervals. The Riemann sum is found by multiplying the width of each interval by r at each left endpoint of an interval. So we get 2 minus 0 times 60. That is the first interval left endpoint, plus 5 minus 2, the width of the interval, times left endpoint, 90. And 7 minus 5 times 110, and 8 minus 7 times 120. And we evaluate it. So 2 times 60 plus 2 times 110 plus 1 and 3 times 90 and 1 times 120 is equal to 120 plus 220 plus 270 plus 120. So the final answer is 730. So that is the answer of question A. Okay, question B. Estimate the amount of grain in the silo at the end of 8 hours using an answer from part A. To estimate the total amount of grain, we need to use the original amount of grain, which is 100 feet squared, plus the grain being loaded and minus the grain being removed. So we can have the expression 100, which is the original amount of grain, plus the grain is being loaded, which we can get by integrating the function g of t. So 400 times e to the t squared over 4 dt, and minus the grain being removed, and which we already had from the question A is 330. So now we just need to evaluate this integral, and the second term we need to evaluate with our calculator. So the answer is then minus 330. So the final answer is 78.982. Okay, question C. Estimate R prime of 5 showing your work. Indicate the units of measure. For question C, we need to use a special method to estimate the derivative of R of 5, because the R function is given by a table. So we estimate the derivative of R of 5 by finding the slope of the secant line from t equals 2 to t equals 5, and from t equals 5 to t equals 7, and averaging the two. So it's like this. So 2 to the 5 and 5 to the 7. We find the slope of this segment and the slope of this segment, and averaging these two numbers. So the first slope is from t equal 2 to 5 is 110 minus 90 over 5 minus 2. So it's the formula is dy over delta y over delta x. So the difference of y over difference of x, so which is 20 over 3. That is the slope 1, and the slope 2 is from 5 to 7. So it's 120 minus 110 over 7 minus 5. So is 10 over 2 is 5. So Next step is average them. So the average slope is 35/6.